Okay, we are live. Anybody have any questions about the assignment? Not that I can answer them, but.
Yeah, I'm not sure.
Okay. All right, well, let's go ahead and start with our quiz then. Let's see. All right, so Rebecca, you said you didn't have your calculator or your computer in front of you?
What?
You said that you don't have your calculator or your computer in front of you?
So I have my mom's laptop,
Okay.
and it doesn't work as good, but I can get into the quiz.
Okay, perfect. Okay, so question number 3 says, use the following information. Suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is 0. The alternative hypothesis is not equal to 0. And the population standard deviation is not known. Jordan collects a sample size of 9 and computes D bar as 2.2 and sample standard deviation at 3.3. So the question is, what is the value of the test? So T equals D bar minus our hypothesis, which is 0. So 2.2 minus 0 divided by our sample standard deviation, which is 3.3, divided by square root of our number, which is 9. So I get 2.2 divided by 1.1 equals 2.
I got 2 as well.
Okay. Question 4 says the probability of a p-test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis. So isn't the probability the p-value?
Well, that's what I was thinking at first too, but I just like minused that by 1, thinking maybe it was like the rest of that area. I don't know.
So you took 1 minus 0.0403, or you took
Yeah, that's what I did, but I'm not sure if that's right or not.
I don't know. I really have no clue on this answer. What do you think, Casey?
Because it says in the like less than 12 that the p-value should be to the left of t, and so that would be the area. That value greater than or whatever. Maybe that's like the area in front of the t value. I don't know.
So did you plug it into the applet? Is what you're saying?
Let's see here. Into the applet. Let's see. Okay. Well, that wouldn't make sense. I don't know. I'm kind of stumped on that one.
So my definition from lesson 9, the p-value, I said, this is what my note says. P-value is the probability of obtaining a test statistic at each of the extremes you calculate. And so that question says the probability of obtaining a test statistic greater than his test statistic. And then it says use that to determine the p-value. So I just put 0.040.
Huh.
I don't know.
You're probably right. I don't know. This is confusing to me. You're
Yeah,
probably right.
I'm confused.
You're confused too?
Yeah, I'm looking it up right now, and it's
Where's flat coming? Okay, let's come back to that question then. I'll write it down and we'll come back to it
okay.
when Flat joins us because maybe he has an explanation. All right, so I will go ahead and share my Excel screen for this next stuff.
Okay.
Okay. Who wants to read the question?
I can read it. So question 5, right?
Yeah.
So use the data from Excel sheet to answer the next 6 questions. Perform paired samples t-test in SPSS. Be sure that the test is group 1 minus group 2. Use null hypothesis, mapping, and alternative hypothesis that is not equal to 0. And the level of significance of 0.1. What is this test statistic?
Okay, so I'm copying and pasting here. Group 1 minus group 2. And what was our confidence level?
So it says the level of significance is 0.1. Does that mean our level of confidence would be 90?
Yeah, 90. Okay, and then our null hypothesis is 0?
Yes.
Okay, and then are we
Yeah.
doing? I'm sorry.
Not equal to.
Not equal to. Okay, there we go.
Not
That's
equal
good.
to. Yeah.
Okay. Okay, so I think I have that all in there.
Point.
So the test statistic is E.
0.407.
Yeah.
Okay.
The p-value is the next one.
If we're on a not equal to,
0.6.
it's 6, 8, and then we're going to round 6 at 9.
9.
So 0.689.
Mm-hmm.
Yeah.
Okay, so then what is the correct equation? So we're at
So-
0.1?
So then we fail to reject it, or wait. Oh. Gosh.
So our
I always forget
p-value,
if it's above or below.
our p-value is larger
insignificant.
Then is significant. So we will, what will we do? We will fail to reject.
Okay.
Okay. Then it says, suppose your alternative hypothesis is greater than 0. Let me go back here. We change this to greater than. And that changes our p-value. 2.344. But that's still bigger than 0.1. So we're still going to fail to reject.
Yeah, because our level of significance would stay the same, right?
Yeah. Okay, but then I'm confused on which one of these wordings is correct.
Okay, so we have insufficient evidence. It's one of the first two.
We have insufficient evidence that the
It's the
mean
second
is
one.
equal to, or the mean is good. Okay, so it's the second one. Okay. All right. So now we'll go to the other group B. Okay. Now copy and paste again. Okay, it says group 1 minus group 2. I think I got that. The hypothesis is 0, not equal test, and our confidence level is 99. Okay.
It's greater n or yeah.
Or degrees of freedom. N is greater.
Yeah.
Okay. And the p-value is right there. 0.0012. Okay.
So it's roughly the same as our level of significance.
0.001, and then our level of significance is what? 0.01.
Oh, it's 0.01, so it's smaller.
So it's smaller. Okay, so that means
We reject.
you reject the null. Okay.
Okay, you decide to try another alternative hypothesis. This time we are greater than 0.
Okay. So I will go back and change this to greater than. Okay.
What does that do to our p-value?
So our p-value is now 0.0006.
So it went smaller. So it decreased.
So it decreased, okay? And so what decision do you make? The same decision, right?
Yeah.
Okay, so we reject the null.
Question 14. Based on your response from the previous question, what conclusion do you make? So we rejected it, so we have sufficient evidence
So it's A or C. We have sufficient evidence that there's no difference or that there is a difference. Oh, man. That there is a difference, right?
Yeah. That's what I'm thinking.
Because we are rejecting the null, which says there's no difference. So
Right.
we have sufficient evidence that there is a mean difference, so that would be C. Is that right? We'll see when we take the quiz, right? Guess we can always take it twice. All right. Question 15. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? I have no idea.
Well, okay, hold on. So,
It wouldn't be the two-tailed, would it? Because, well, because you're... Wait.
it decreases when we changed it from not equal to greater than.
Mm-hmm.
Which makes sense because you'd be cutting the two-tailed test in half.
Right.
But that's kind of weird because I would think that less than and greater than would be the same.
Or does it just depend on the problem? In general, which alternative hypothesis? Well, I'm going to go back to the spreadsheet here.
Yeah, just try flipping through some of those hypotheses.
Try it. Okay, so if we do greater than, we have 0.006. If we do less than, our p-value is big.
Huh.
It's 0.9. If we do not equal to, it's 0.001. So it's smaller. It's bigger than the, not equal to is smaller than the less than.
Okay, now that I can see that, it kind of makes sense a little bit. It's probably highlighting, like in the applet, probably all of it when you're doing greater than. Or maybe not, I don't know.
Oh, wait, yeah. Is that right? Yeah, because the greater, you're right. It does highlight more on the up. So would it be the less than? No, wait. Let's see. Because the less than gave us the biggest p-value.
Right. So I guess the opposite of what I said.
So greater than gives us the smallest in this scenario. But is that true for all the scenarios? Should we go back and try it on like our
Try changing the null hypothesis.
So if I change the null hypothesis to 1, my greater than is, my less than is bigger, and my not equal to is small. So did that stay the same? Because the less than was bigger, and the greater than was smallest. And that's still the same if I change the null. The less than is biggest.
What if you change the null hypothesis to like a really large number, like 10.
Okay, so then I've got it at 10. My not equal to is 0.5. My less than is 0.7, and my greater than is 0.2. So it is holding true on all of those that the greater than is the smallest.
So then that's probably for all problems.
Yeah, I agree.
So is that A, B, C, or D? Is that D?
I think so.
Hope so.
Okay. But I still don't totally get it, but okay.
I don't either.
I'm trying to picture it on the applet like you were talking about before, but I
have no idea.
Okay. Well, we'll just we'll keep moving and see how it turns out when we score it. All right. So, are we still on the same? We have the same input here, but I got to change this back to 0.
Okay, the next information says determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2 and put your answers below. What is the point estimate for the 95% confidence interval?
Okay, so I changed our confidence level here. Our null hypothesis is still 0, and our type. Does it matter if we change our type of test? Let's see. Nope, confidence level stays the same. Okay.
So the point estimate.
What is the point? What is a point estimate?
I don't know.
So the point estimate should be the mean, right?
Oh, okay.
Wait, is it the mean or is it the T? Oh, gosh. I think it's the mean, though.
I think you're right. That sounds right. Because that's our point, right? Okay, so our mean is, if we go back here and look, so is that our T or is it our mean? I think it's the mean, isn't it?
Yeah, I think it's the mean.
So 11.955. And what is the margin of error for this interval?
So that we would have to calculate. Right? It
Okay,
doesn't
so
show
we have
up
to
on
calculate. Okay, so what's our formula?
So that should be X bar. This would be not the X bar, but the
So it's 11. Is it 11.955?
Wait, why did I say that? No, it's T times the standard deviation over the square root of n.
Oh, okay.
That's
So
the margin.
T. So that's 3.737 times S, which is 15.003. Right?
Yeah, it's really hard for me to see your
Oh,
screen on
sorry.
my phone, so I'm just
Gotcha.
I'm just going with what you're telling me.
Okay.
Writing it down.
Okay, and then our n, so it's square root of n, which is 22. So square root of 22.
Okay, cool.
So 15 divided by, oh, no. 15.003 divided by square root times 3.7. Okay, so I get 11.953. I don't think that's right. Does that get, what did you guys get?
I'm almost there. Just a minute.
What question are you on?
Oh, Flat, you're here. We're struggling. We're on number 17. So we're trying to find the margin of error.
6.
And this is, if you can see, I've got this thing up here.
Did you say you got 11?
I did. I know I've been doing these wrong.
Okay, I got 1.18.
But see, our confidence interval, it gives us our confidence interval, which is 5.3 and 18.6. And we know that those are mean plus or minus, right? So every time I try to do the actual margin of error, I must have the wrong formula because I don't get it right. So I always just end up taking my mean and I subtract the lower confidence interval from it, and that's where I get the right number at. Because I haven't been able to, I did it on the homework too and got it wrong as well. So I come up with 6.652 for the margin of error.
That does make sense because it should be X bar or D bar or whatever plus or minus times the standard deviation of the square root of n, which is the margin of error. So it makes sense that it would do that.
I can't hear you. What were you saying?
I'm sorry.
Casey, what are you coming up with? Can you hear me, Rebecca?
Yeah, I can.
I can hear you.
Okay, I can barely hear you. Can you tell me again what you did?
Okay, I actually did it wrong the first time. So this
Okay.
time, I'm pretty sure I got the same thing as you. I got 11.953.
Yeah, but I don't think that's right. That can't be right because if we because that's pretty much that's the mean. It's not the margin of error.
Okay, well, the mean should be what your let's see here. What's the mean? I'm confused.
Yeah, so the formula that you did, if we're plugging in the right numbers, we get 11.953, but that can't be the margin of error because then you're going to take your mean and subtract it. You're going to add and subtract from that. And that's basically the same number as the mean. So that would make our confidence interval 0 and then like 22. Because we're plus and minusing our confidence our margin of error from our mean. Does that make sense?
Yeah, it makes sense.
Yeah, I mean, because that's the exact formula that I have too.
Formula.
Yeah, I just tried it and got the same thing.
The 11.953.
Yeah, so I'm just as lost as you
Yeah.
guys.
So like I said, what I've been doing, and I think on the homework part, I think I missed it the first time, so I went back and did it again. Because our standard of error is how we get our confidence interval, right?
Right.
So if we take our mean and so I'm going at it a totally different way because every time I use the formula that I have, I don't get it right. So if I take the mean, which is 11.955, and I subtract my lower confidence interval, which is 5.303, and then I add, I'm trying to go back. So I take this and I subtract this from it. I get 6.652. So then if I take this number and I add 6.652, I get this number, basically. Right?
Yeah, I think that makes sense.
But that totally doesn't go with any of my formulas I have written down. So I'm screwed. But it makes sense, right? Any comments, Flat? You know what's going on?
It does
We're
make sense.
Well, I kind of jumped into the tornado, so I'm trying to gauge what's going on.
Sorry. This is tornado. We are all completely.
That's okay. How about we come back to this one
Okay.
and then go to the other two, and then I will see what I can help you all with on that.
Okay.
17.
All right. Oh, we need your help on number 4 as well. Okay, so then number 18 just says input the lower bound, which we have on our sheet here as 5.303. And then the upper bound, which is 18.607. Everybody there and understand that one?
Yeah, I understand.
Okay.
So I missed question, what was it, 11 through 14, because my computer was not working.
Okay.
Do you mind going back to
No, no problem. Okay, so we need to go back to 11?
yeah.
Okay. So to get to number 11, we have to talk about number 10. And so on number 10, our p-value is 0.001.
Yeah, I have that down.
And our level of significance is 0.01. So for question 11, what decision do you make? Our p-value is less than our level of significance.
So then we fail.
And so we are rejecting the null hypothesis.
Oh gosh, I always get confused whether it's above or below.
That's why I always have to look at my notes every single time.
Okay, so if it's less than the level of significance, then we reject the null hypothesis.
If the p-value is less than the level of significance, we reject the null. Yep.
Okay. I always mix that up and never remember. So then
Okay, and then back to question 12, it says you decide to try another alternative hypothesis. And so this time, so we're going to go into here into our spreadsheet, and we're going to change this to greater than,
which decreases our p-value, right?
which decreases our value. Yep.
So then, oh yeah. Okay. So the p-value decreased.
Mm-hmm.
Alright. So then we still reject the null.
Uh-huh. Because it got even smaller. And then question 14, based on your response from the previous, what conclusion do you make? So we know we're rejecting, so we have sufficient evidence. So that gives us A or C. And
Why do we have sufficient evidence if we're rejecting the null? Oh, because, okay.
yeah, because if we weren't rejecting the null, then we would have insufficient evidence. But because we're rejecting it, then we have evidence, but then we have to just decide what we have evidence for.
So there isn't a difference.
There is a difference, yeah.
There is, oh, this is so like confusing.
Yeah, because our hypothesis said, let's see, if I go back up here, our hypothesis is saying there is no difference. The null hypothesis says there's no difference
Okay,
because it's equal to 0. And so we're saying, you know what, there is a difference because we're rejecting the null.
All right, awesome, thank you. You make it so clear.
Yeah, it's totally confusing.
Okay.
I'm interested to see what we're going to get on this quiz. Okay,
Me too.
so now that we have flat here, let's go back up to number 4 really quick.
Yeah, let's see how much I help on this one.
Okay, so what our question is on 4, it's, okay, so here's the question. Are you in front of your computer at all, Flat?
Yeah, I am right now, so I'm trying to grab my notes and stuff, so go for it.
So 4 says the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. And so I say that the p-value is the probability. So it's 0.040, but Rebecca was saying that we need to subtract 1 or something, and we really don't know. So, any insight?
I'm looking back at my notes. I had this up a little while ago. I got the answer, but I'm trying to see what my notes were for this. did I do here? Hang on. What was the formula that you said Rebecca used? I can't really hear her that well, so I'm not sure if I should ask her or someone else.
So, I was thinking of the normal probability applet, how the entire area is equal to 1.
Oh, there
And
we
so
go.
I just minus what?
No, I was just
So,
saying, I could hear you.
So you just took 1 minus the 0.0403.
Yeah. But I have no idea if that's right.
No, hang on. Let's see. No, that's not right.
Because that would be 0.9.
Yeah, that's not right.
Okay. So what was the right answer? Did you already take the quiz?
Yeah, I got it. It's 0. And I'm trying to get y'all so that you can have an idea of how to get it. I might have to revisit that one with y'all.
Oh, let's see. Okay. Where are we? Are we still on number 4?
Yeah.
Okay. So Flat, what are you coming up with?
Sorry, I'm in between 2 different things.
So, Flat, you got the right answer. Your
your right answer was not 0.919?
No, it was 0.081.
Ah,
Oh my.
Fred.
0.081 is the probability?
Yes.
Ah, and you don't remember how to get that.
Whoops.
Oh, but wait, what if we go to the T app and put in the 0.403? 0.0403 is our T score, right?
Yeah.
And we have how many degrees of freedom here? We've got 8 degrees of freedom. And what's the probability of scoring greater than that? Is that what we're looking for? But I'm still not on my...
Say that again.
Okay, are we on the T probability or are we on the normal probability app? I bet we're on the normal app. Here's a link to the normal probability app if you need it. Okay, so if we put in his score here of 0.0403, what did you say you got for your... No, never mind.
0.081.
Oh, I'm totally lost. The value of the test statistic is 2. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.040. Okay, so we said that his test statistic was 2, right?
Yeah.
So if I go to the normal probability app and I put in 2 because that's his score, that's his z-score, right? It's 2. The probability of scoring greater than that is 0.0228 on the normal probability applet. And on the T app, it's 0.0403. So use this probability to determine the p-value for Jordan's hypothesis test. I have no idea. You can't tell us how you got to the 0.081?
Now I'm looking back at my notes, and I'm trying to remember. Unfortunately.
Hmm.
Okay. Well, what was our other one that we had a question on? 17? No. Yes.
Yeah.
The margin of error. Okay, so I went a little bit further back in my notes. And the margin of error is our z-score times our standard deviation divided by the square root of our sample size. So just going back to basics, if we're at a 95% confidence interval, then we're actually multiplying our z, which is actually 1.96, because that's the value of the 95% interval on the normal probability app. Does that make sense?
Yeah, that makes sense.
So if we take,
Yeah, that totally makes sense.
rather than taking our t-score, which I don't know why I have that written down on the, anyways. So if we take the 1.96 times the 15.003 divided by square root of 22, then it gets us a little bit closer to being in our level. It doesn't give us our mean number anymore.
That's right.
Divided by square root of 22. I get 3.19865 times 1.96, which gets me 6.269.
That's what I got too.
6.269.
Yeah.
That's the margin of error.
I think that's the margin of error. Which is going to give us different numbers than our actual, if that's what we put in for our margin of error, then that gives us different numbers on 18 and 19 than our spreadsheet gives us.
What you got for 18 and 19? 5.303, is that right?
Uh-huh. That's what our spreadsheet gives
607.
us. Uh-huh. Yeah. Okay, so I'm gonna opt for this for this one. I'm probably going to end up taking this quiz twice. I'm just going to put on there what the spreadsheet has for those two numbers.
That was so 18 and 19 are still 5.303.
That's what that's what I'm going to do and see what it does. Yeah, because we can take it twice. So I'm just gonna go ahead and submit what I've got and see what it gives me, and then that might help us to go back and see what we got wrong. Okay. So I got question 4 wrong because I put in .040, and I got that wrong. And then I got question 15 wrong. And question 17 wrong, but I got 18 and 19 right.
What did you put for 19?
18.607.
Okay.
So I went off of the spreadsheet. So I'm guessing that if I go back and do it the original way that I said to do it and put in 6.652 for question 17, I'm guessing I'm going to get it right. Because I'm just taking my X bar and I'm finding middle ground there rather than doing a formula.
So you said 6.652 for number 17?
That's what I'm going to put. I put in 6.269 because that's what my formula gave me when I...
Well, you can only take it twice, so let me submit it with that answer and see if it's...
Okay, with the 6.652? Okay.
Yeah.
Okay.
Did you say you got number 15 wrong too?
Yeah, I got 15 wrong.
So do you think that one ended up being not enough information?
That was what I was going to do on my next one.
I changed 15 to not enough information, and it is right.
And that's the right one?
Yeah. Okay.
What about
and then 17 is the correct answer. 6.652.
Okay.
6.652?
Uh-huh, 6.52.
Yeah.
And then 19 you said was 18.657.
No, 0.607.
Oh, okay.
And so we still have question 4 wrong, right?
Yeah. Well, and Flat said it's 0.081, but I have no idea how to get to that.
Yeah. 0.0. Okay. Well, I've got to go.
Okay.
So.
No problem.
Yeah.
No, thank you. Yeah.
So thank you very much. I'll talk to you guys later.
Okay, bye.
Bye.
Are you still with us, Flat?
Yeah, and I was looking at something that I did in the earlier this afternoon before I had a call.
Uh-huh.
I see how I got to number 3, so I'm looking at my notes from there.
Okay.
And I'm looking to see how I got number 4. So,
okay.
I mean, if y'all want, I can send you the information on how to get it. Once I find it, so we can, so y'all can just wait on your submission for the next time.
Awesome.
So we don't have to stay on the phone hanging up on this.
0.081. Okay. Yeah, if you could do that, that would be awesome. Because I am completely lost. And I'll keep working on it, and if I come up with it, then I'll send everybody an email.
Yeah, I'll do the same. Verify.
Okay. Awesome. All right. Thanks, guys.
We'll see ya.
All right. Bye.
All right, guys.